Hey everybody, how's it going? It's Thursday morning, I'm rocking my Colts jersey here, um, ready to do some math. So hope you're doing well. You either have just taken your test the last time that you were in school, or you're gonna take it the next time you're in school, depending on what group you're in. But today we are gonna start chapter 3. So I mentioned this, or I might have mentioned this to you if you were in school and I had an opportunity to mention it to you. The beginning of chapter 3 here is just an algebra review. So it's really not that big a deal to do this before you take your test, if that's your situation, because there's nothing here in our lesson today that is brand new to you. It is from Algebra 1 and also from Algebra 2. Please don't take it for granted though, because it's a skill that's going to be used in this entire chapter. It's one of the few skills that are from previous math classes that apply to this course. So obviously, you know, it's pretty important. It's going to be used in this entire chapter. So when I say that it's something you've learned before, please don't just kind of take it for granted and don't worry about it. It is possible that maybe you can go through and do the first part of the notes here on your own, and then you might be able to just kind of fast forward through this video and kind of check your answers. And anything where we don't have the same answer, you can kind of back up and just watch my explanation on that part. That is a completely fine way to use these videos. I have no problem with that. Okay, so without further ado, let me go ahead and share my screen here. Hopefully it focuses. Come on, focus. Do it. No, it didn't. Okay, I'm gonna pause and get this thing focused. All right, there we go. That looks better. Got my face a little bit bigger here for you, because that's a good thing, apparently. All right, let's get started. Let's dive into this thing. So at the beginning of chapter 3, there's a little bit of talk here about linear programming and kind of what linear programming is. I'm not going to worry about that so much right now. I will talk to you about linear programming in class. That's not really something I want to do in a video. It is the overall, you know, objective or topic of this whole chapter. But before we learn about what linear programming is, we just need to learn a basic algebraic skill. And you see here, this chapter is linear programming using the graphical method. We'll have another chapter later on that uses a different method to solve these linear programming problems. But that's later on. Okay, so for now, I mean, you can read this stuff up here and kind of get an idea of maybe what linear programming is, but we're just going to review graphing linear inequalities and then also graphing a system of inequalities. And we ought to be able to do this pretty quickly. So this is really a review of graphing a linear equation and then shading it to graph the inequality. So here I have an inequality. I want to graph all of the ordered pairs that are solutions to that inequality. I'm going to come back here in a little bit and make sure we understand what it means for an ordered pair to be a solution to the inequality. But if I'm going to graph this thing, it's linear, so there's going to be a line involved that I need to graph. And so I'm going to change this thing into slope-intercept form. And I'm just going to graph a line. So my first step here is going to be, I'm going to kind of not worry about the inequality right now. I'm just going to think of it as an equation, and I'm going to graph the line that represents this equation. And remember, to do that, the easiest way to do it is to change it into that slope-intercept form. There are other ways, and we can discuss those, but for now, let's just change in the slope-intercept form. So you're going to have to rely on a little bit of algebra skills here to be able to take this equation and solve it for y. In the past, students are pretty good at this for the most part. If you need some help with that, I'm happy to offer you that help. No problem at all. But I will go ahead and just kind of explain. I'm going to subtract the 2x from both sides. So if I subtract 2x from both sides, the left side, I'll just have negative 3y. And on the right, I'll have negative 2x plus 12. And then I'm going to divide everything by negative 3. So this first term will just be y. Negative 2x divided by negative 3 will be positive 2/3 x. And then 12 divided by negative 3 is negative 4. So this is the line that I need to graph. And I'll tell you what, for this example, look ahead here a little bit. Well, we'll go ahead and do it this way. Now I need to go back and consider this was an inequality. All right, and I want you to look at what would happen if we had solved this as an inequality. So this first step, instead of equals, it was less than or equal to. Then we subtracted the 2x from both sides, and so this would be negative 3y is less than. And then the next thing we did was we divided both sides by negative 3. And hopefully you remember from your algebra classes, and if you don't, I'm reminding you now, that anytime you multiply or divide both sides of an inequality by a negative number, then that inequality has to flip around. So the less than becomes a greater than. Okay, so I just wanted to start by just reminding you how that kind of equation solving process works, and then look at what happens when it's an inequality. And in this case, we end up having to flip that symbol because we divided by negative 3. All right, I'm going to use my slope-intercept form here to graph a boundary line, and I'll explain that a little bit more in a minute. But I'm going to have a y-intercept at negative 4. Hopefully you remember when we graph lines, this number at the end, which is the b, right? That's your y-intercept. So I'm going to graph negative 4 on the y-axis. This 2/3 is your slope. So that's your rise over your run, which means you go up 2 and over 3. So I'll start at my y-intercept. I'll go up 2 and over 3, up 2 and over 3. I won't be able to fit another point on there. I also could go down 2 and left 3, because a negative over a negative is a positive. So if I went down 2 and left 3, 1, 2, 3, there's another point. Now do not connect those points yet. Here's why. If we connect those points and we make a solid line, what we're saying is that every point on that solid line is a solution to this inequality, and it's not. Every point on that line would be a solution to this equation, y equals 2/3 x minus 4. Do you see how there's no or equal to here? It's just greater than. There's no or equal to. We don't want to include the equals part. And the points that are solutions to the equals are the points on that line. Instead, this line's going to serve as a boundary. So instead of drawing a solid line through these points, I'm going to use my ruler here to try to do a really good job of this. I'm going to draw a dotted line through those points. Okay, and I make this dotted because there's no or equal to. It just says greater than. Okay, so what this dotted line does is it separates the points that are solutions to this inequality and the points that aren't. Your solution points are either going to be found above the line or below the line. Now there's a couple ways that we can determine where those solutions are. One way is to just pick a point, find if it's a solution. If it is, great. That's the side the solutions are on. If that point is not a solution, then fine, the solutions are on the other side. See how that works? So let's check a point. So let's pick an easy point. How about 0, 0? You should always check 0, 0 if you can. It's the easiest one. So let's say, is 0, 0 a solution to, and we always want to go back to this original problem, 2x minus 3y is less than 12. So I'm asking that question, is 0, 0 a solution to that? So if I put 0 in for x, then it's 2 times 0 minus 3 times 0, because I put 0 in for y, is less than 12. Now 2 times 0 is 0, 3 times 0 is 0, so 0 minus 0 is 0. Now this says 0 is less than 12. Is that a true statement? Of course it is. Yes, 0, 0 is a solution to this inequality. So there's 0, 0. Do you notice how 0, 0 is above our dotted line? That means that all of the points above that line are solutions to that inequality. We can pick any other point we want. I don't know, how about 3, 5? 3, 5 is above that line. Watch what happens if I check 3, 5. So I'm going to check the point 3, 5. So I'm going right back in here, putting 3 in for x and 5 in for y. So 2 times 3 minus 3 times 5 is less than 12. So 6 minus 15 is less than 12. That means -9 is less than 12. Is that a true statement? Is -9 less than 12? Of course it is. 3, 5 is a solution. But I knew it would be because it was above the line, and all of these points above that line are solutions to this inequality. So this dotted line is just the boundary between the points that are solutions and the points that aren't. Now, there's actually an easier way to do this where you can avoid checking the point. And for that, all you need to do is go back here and see that that symbol is a greater than. Greater than means more than, right? So greater than means the solutions will be above the line. You have to always think above or below, never left or right, always above or below. Greater than tells you that the solutions will be above the line. If that was a less than, then we would shade below the line. Now, the one thing you have to be careful of with this, that look at the symbol in the original inequality. It was a less than. Remember how we had to flip that less than in our work here because we divided by a negative? So if you're going to use this trick, you have to use the symbol that's present after you have put this in slope-intercept form, okay? Let's go on to the next one. We'll just do a few more here. Okay, example 2, they want us to graph this guy. First thing I'm going to do is put it in slope-intercept form. So I need to solve for y, so I need to subtract the x from both sides. That means 4y is less than or equal to -x plus 4. Then I need to divide everything by 4. So y, if 4y divided by 4 is y. This is a -1x. So -1x divided by 4 would be -1/4 x. And then this 4 divided by 4 is 1. I'm going to plot my points using my y-intercept at 1. So I'm going to plot my point on the y-axis at 1. My slope of -1/4. A slope of -1/4 means go down 1 and right 4. So down 1, right 4, down 1, right 4. Or we could go up 1 and left 4 if we just move the negative to the bottom. So up 1, left 4. So there's a few points. Now this does have the or equal to on it. So this time I do want to include the points that are on this line. Okay, all the points on the line are the solutions to y equals -1/4 x plus 1. And we do have the equals here, so I do want to include those points, so I'll use a solid line. You'll notice here that my symbol is a less than or equal to. Less than means below, so all the solutions will be below that line. That's all there is to it. If you would rather check 0, 0 again by plugging it in, that's fine. All right, we're moving right along here. Example 3 says x is less than or equal to 3. There is an or equal to here, so the first thing I'm going to do is to graph the line x equals 3, and this tricks some people up sometimes. What this means is that every point on this line has an x coordinate of 3. We want a line where every point on that line has an x coordinate of 3. Let's plot a few points that have x coordinates of 3. How about 3, 0, or 3, 1, or 3, 2, or 3, -1, or 3, -2. See what's happening here? We are getting a vertical line. You can also think of this as that it is a line that crosses through the x-axis at 3. Okay, so that's x equals 3, and I drew a solid line because this does say less than or equal to. Okay, now let's do the less than part, and this is the only time that you think left or right, because there is no above or below this line, right? We want to graph every point that has an x-coordinate that is less than 3. Now, all the x-coordinates that are less than 3, they're all over here to the left of this line. And so we are just going to shade everything to the left of that line. There we go. Okay, next one is y is greater than 2. So let's start with our boundary line. And our boundary line is going to be the line y equals 2. So let's graph some points that have y coordinates of 2. So that could be 0, 2, or 3, 2, or 6, 2, or negative 2, 2. You see what's happening here? We're getting a horizontal line. Now, since there's no or equal to on this one, my boundary line needs to be a dotted line. So I'm going to make the line y equals 2 a dotted line because there's no or equal to. It does say less than. Less than means below. So we're going to graph every point that has a y coordinate less than 2, which would be all of those. All right, moving right along here, we're almost finished. We've got 2 more problems here and we're finished. And the only thing here is that these are going to be systems of inequalities. A system of inequalities is when you find ordered pairs that solve more than one inequality. All I'm going to do here is graph both of these inequalities on the same graph. Watch how this works. I'm going to start with y is less than negative 3x plus 12. Now that's already in slope-intercept form. Awesome. I'm going to plot a point at my y-intercept, which is 12. I'm going to use my slope of negative 3. Now remember, that means negative 3 over 1. So I'm going to go down 3 and right 1. So down 3, 1, 2, 3, right 1, and let's plot some points. 1, 2, 3, right 1. Down 3, right 1. Down 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. Okay. This does not say or equal to, it just says less than. So I'm going to make this line dotted. There we go. That's the boundary line. It says less than means below. So I'm going to shade below this line, but I'm going to shade really lightly. Okay, because these are not the final solutions to the system. They are just solutions to that first inequality. So I've shaded that nice and lightly. Now I'm going to do the other one. And this looks a little bit weird. It's actually going to be easy. But you see how the y is on the right side of this? We want the y to be on the left, right? So I'm going to flip this around and make the 2y on, and actually I'm going to use green for this. I'm going to put the 2y on the left and the x on the right. But notice with an inequality, if I'm going to flip sides like that, I'm also going to have to flip that inequality. Okay, so to solve for y, which is what we do when we put in slope-intercept form, we need to divide both sides by 2 here. 2y divided by 2 is just y. X divided by 2 would be 1/2 x. And you might be asking, like, that looks weird. How are we going to graph that? What if I make it easier and just do this? Right? That's really all that's going on. So our y-intercept is 0. So I'm going to put a point at 0, 0. I'm going to use my slope of 1/2. Which means up 1, right 2, up 1, right 2, up 1, right 2, all the way across. Or I can go down 1 and left 2. Down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. There is no or equal to on this. So again, I'm going to make this boundary line a dotted line. There it is. The inequality says greater than, which means I need to lightly shade everything above the green line. you'll notice that there's an area on this graph that has been shaded twice. That area is the solution to the system, and I'm going to do that with pink highlighter here, and that's this area here, which is above the green line and below the red line. That's my final solution area to this system. Every ordered pair in this area is a solution to both of these inequalities, and that's what we do with a system. We find the solutions to both inequalities. Okay, we got one more to do. Let's knock it out and we'll be done. So we're going to start with x is greater than 2. Remember, when there's just an x, we want the points whose x coordinates are 2. This is going to be a line that crosses through the x-axis at 2. We need to make sure it's a dotted line because it just says greater than. It doesn't say greater than or equal to. So I'm going to do a dotted line through the x-axis at x equals 2. Okay, the next, oh, and then we have to shade. That says greater than, so I'm going to lightly shade the points that have x coordinates bigger than 2. The next one looks a little bit strange. It says -4 is less than or equal to y, which is less than or equal to 3. All this means is that we want the points whose y values are in between -4 and 3. So y values bigger than -4 and smaller than 3. So I'm going to start with some boundary lines here. One boundary line will cross through the y-axis at -4, and the other boundary line will cross through the y-axis at 3. You'll notice that I'm making these solid lines because it does say or equal to there. Now we want the points whose y coordinates are in between those numbers, so I'm going to lightly shade in between the green lines. See how this part now got shaded twice? Keep that in mind. Okay, lastly, we've got x plus y is less than or equal to 7. Let's put that in slope-intercept form and graph it. So I'm going to subtract x from both sides. Y is less than or equal to -x plus 7. That's slope-intercept form. Y-intercept is 7. So I'll put my point on the y-axis at 7. Okay, minus x means my slope is -1. So that's -1 over 1, which means down 1, right 1. Down 1, right 1, all the way across. It also means you could put the negative on the bottom and go up 1 and left 1. So up 1, left 1, all the way across. There is an or equal to on this. So I'm going to go ahead and make this a solid line. There we go. The inequality says less than, so I'm going to lightly shade below my black line here. Now I want you to pay attention to what area has been shaded all 3 times. The area that is to the right of the red line, it's in between the green lines, and it's below the black line. And you should notice that it is this area in between. It's kind of this enclosed area here. So I'm going to make sure that it's really evident on my graph that that area is my solution area. That area represents the solution to this system. Every point in this region is a solution to all 3 of these inequalities. Okay, guys, that's it. That's your review over graphing linear inequalities and systems of linear inequalities. Next time I see you in class, I'll have a little activity for us to do, or you'll be taking your test depending on what group you're in or whatever. Okay, so awesome. Like, comment, subscribe down below, even though the comments are disabled and I don't keep track of my subscribers. Maybe I'll get like monetized by YouTube if I get enough subscribers. How does that work? And we could all, I would share the money with you so much. I would totally share that money with you. I would bring in breakfast like every day. I'm kidding. This is not a way for me to get rich. Joking. All right. Have a good day. Bye.